All right, welcome back. So I've got about a good half an hour here. So I'm going to do some more coding. I know I've had requests to go back to my certifications, which probably makes the most sense for my career. I think people have been enjoying my series where I just read books. It can be a good like a free replacement for like an audio book if you're doing a long trip. But I'm just, I think in this day of an age of AI, if you could because remember, we're right at the beginning of this thing. Like the big AI moment where if you think of it in terms of the pandemic, like we're in January of the pandemic where it was isolated to China. It was like a small story in the back of the paper. Oh, this thing is happening in China. It's way off in China. Who cares? That's where we're at with AI. So we're going to enter um, February where it's like anyone who's like not a um, I think the word is artard is like starting to really catch on and be like, oh, this could be a big problem. And then March, like things actually like shut down. So like that's where we're at with AI. But I think we're there on a yearly basis and not a monthly basis. So I think 2025 is kind of similar to the January of the 2020 pandemic. 2026 will be more like February, where you'll have deniers or like people who just aren't treating it seriously or just like aren't kind of you know aren't really uh, kind of I, well, and then and then 2027 will hit, and as we read in Situational Awareness by Leopold Aschenbrenner, that's when nobody can ignore it. And the people that do are just, so obviously wrong about it that despite them maintaining their popularity and getting reelected, um, society at large behaves differently. So we're going to have that moment, I think, sometimes around 2027. If it came earlier, I wouldn't be surprised necessarily. Gertzel, one of my favorite computer scientists when it comes to AI, I just love listening to the guy talk. He says it could be as soon as 6 months. So that's a really big prediction coming from him. Um, if it comes later than 2027, um, I would, that might make sense because there are limitations with the current approach for sure, and they're going to have to, I think, at some point, do an about face and use a different technology. But that's an algorithmic improvement. Like that's not, it's not like we're trying to build cars and we just realized that like you can't build a car or like a better analogy would be like we're trying to build a plane and then we realized that you can't build a plane that doesn't flap its wings, so now we have to build a wing flapping mechanism, and it takes us 100 years to figure that out. It's like if it is the case that like LLMs like and our current approaches to AGI are not effective, I think switching to a new approach of AGI will maintain the current timelines. I think we'll still have that big moment in 2027 where everyone has to take AI seriously and talk about it in a different light. So, and that's whether we get that, and that's just the rate of growth of our current approach to it, which might not even be optimal or even able to produce real AGI, but um, we're still having researchers research other ways. So it's just a part of this multifaceted, unstoppable growth of AI, where we have for where any limitation is dwarfed by the advances in other areas. So, so I think learning how to work with the AI, learning how to use the AI effectively is a unique opportunity, especially at this time in the world where we're kind of at the January or February during the pandemic, because some of the big winners during the pandemic were those that like sold off their stocks beforehand and didn't get affected by the dip in the stock market. People who invested in a portfolio of companies like Moderna. So I feel like to some extent you can kind of do a behavior like that, and I think that behavior would be the people who like use it to learn how to create income because it can teach you these novel wealth strategies that like people who are already successful, grew up with and did throughout their whole lives and learned from their parents. Like there's no longer that like barrier to knowledge. So like I think it can help you bring in like a diversified streams of multiple sources of income, which is kind of like the nowadays with everything that's so like unpredictable. You don't like work at a company for 30 years and receive a pension the same way you did before. Having like a robust stream of multiple forms of income is like the gold standard to wealth, in my opinion. So yeah, I'm working on the world's greatest metronome. Right now, I'm just developing it as part of my GitHub pages. At some point, I will probably buy my own domain name from a registrar, whatever that domain name happens to be, and then um, and then host a website using a hosting platform, be it Ghost, AWS, whatever there is. I think WordPress is one too. I don't even know. So at some point, I'll definitely put some money into that, and then try to do a bit of e-commerce, sell access to the browser metronome, just like a subscription thing. Like you can sign up for $10 a month to my site and get access to like all the things, give a demo. So especially if AI becomes sophisticated enough to do that, because there's people that do that now, but they're like not sole proprietors. But anyways, let's continue work um, on this metronome. So where I was last, um, I what I did was just read through the code because I didn't write this code. This code was written by the AI. So I don't understand a lot of it. So my goal was just to go line by line and read each line. Now, some of the code is more complex than others. HTML I think is pretty straightforward. It's just wrapped in tags, and the tags do like communicate to the browser like what to do. So that's pretty easy. CSS is a bit more complicated, so I was pretty happy with reading through all of the CSS code. Um, but there was a point where like it really wasn't more that complicated. It was more complicated than the HTML for sure. But once you just figure out, it's like, oh, you have a selector and you have a declaration block with declarations inside of it. So the selector basically points to or selects some element of the page that you're going to make declarations about to change its properties on the page. So if you just so like body on line 8, like where did that come from? Well, you can select an HTML tag. So we're selecting the HTML body tag, and then we're making declarations about how anything wrapped in that should appear on the page. So we're getting the font, we're getting the margin, the background, all of that are declarations for how it should appear on the page. So you can do that with any HTML tag that belongs, yeah, that displays stuff on the page. You can do that with HTML attributes such as class. So if you create a div, if you create two HTML div tags sections on the page, you can give one a class equals like the first one, the second one class equals the second one, and then you can affect one but not the other by putting a dot in front of the class name and targeting the class rather than every instance of the div tag used on the page. Similarly, you can do that with ID equals, and you use a pound sign for that. So it's pretty self-explanatory. You can use multiple selectors. So if you put a selector commas after a selector, you can use multiple selectors. You can also kind of nest into selectors. So like if there's a an element with the ID class, and then it's wrapped around another HTML tag, for example, called like label. You can drill in and only affect the label within that by just adding a space between them, and then it drills into the nested elements, and you can hyper target with a scalpel specific elements on the page that you want CSS declarations to modify. So yeah, really makes sense to me now. I'm gonna pause it. I'll be right back. All right, I'm back and I'm in VR. Like to work in VR. So let's see here. So yep, let's start a conversation with ChatGPT and see if I can learn the code enough to work out all the bugs. Hey, how you doing today? So it's 11:48 a.m. I need to be somewhere at 1:30. It'll take me about a half an hour to drive there, a little less. So I have to be out the door at 1. So I've got probably a good hour here, maybe more like 45 minutes or half an hour because I gotta like shower and change and all that. And let's work on the code. Do you remember when I would read the code line to bottom, the code for the metronome, and you would teach me, like you taught me a lot about CSS? Do you remember that?
Hey, I'm doing great. Thanks for asking. Yeah, I remember those coding sessions for the Metronome project. We went through the code line by line and focused on the CSS and other aspects. We can definitely pick up where we left off or tackle any new issues you've got. What part of the code do you want to dive into today?
All right, so I'm pretty satisfied with the HTML style tag, the CSS. I feel pretty good about that. I feel pretty good about HTML itself. It's just really self-explanatory to me. Where I really kind of struggle to understand what's going on is the JavaScript under the script tag. So let's start with line 225. That's where the JavaScript begins.
All right, let's dive into the JavaScript. Starting from line 225, the script tag usually contains the logic that makes the page interactive. If you can give me a quick rundown of what the script is supposed to do or any specific parts you're struggling with, I can help break it down. Are you dealing with event listeners, variables, or maybe a specific function that's tricky?
Yeah, but let's not do that. Instead of just a quick rundown, let me read you line by line what's going on, and we'll discuss that line.
Sounds like a plan. Go ahead and read out the first line you want to discuss, and we'll break it down step by step.
All right, so this is line 225. It says document.add event listener, and then it has some parameters passed to it. So let me read it to you exactly. So then it says open paren quote DOM content loaded That's wrapped in quotes. Then it has comma, open, close, paren. And then it has equal, greater than sign, so like making an arrow. And then it has a open curly brace.
Got it. That line is setting up an event listener that waits for the entire HTML document to be fully loaded and parsed before running any code inside that arrow function. Essentially, it ensures that all the HTML elements are in place before the script tries to interact with them. So anything you put inside those curly braces will run only after the document content loaded event fires.
Okay, and what is an event listener?
An event listener is a function that waits for a specific event to occur and then runs some code in response. In this case, the event is DOM content loaded, which means the listener is paying attention for when the initial HTML document has been fully loaded and parsed. Once that event happens, the function you provided gets executed. This way, you can make sure that your code won't run too early, like before the elements you want to manipulate even exist on the page.
Okay, that makes sense. It's just the word listener threw me off because I'm building a metronome. So like I thought listener might talk about like the audio elements that I'm adding to the metronome, but it sounds like a better word besides listener would be something like contingency. So like instead of like add a event listener, it would you could rewrite it to be like contingent upon.
I get what you mean. The term listener can definitely sound confusing, especially in an audio context. It's basically saying, hey, when this specific event happens, run this function. Thinking of it as contingent upon or triggered by the event makes perfect sense. It's just a common programming term to indicate that the code is listening for something to happen before acting.
Yeah, I like W3 schools. It's been really good. So let me read to you what it says about JavaScript event handlers.
Sure, go for it. W3 Schools has some great explanations and examples, so we can definitely use that as a reference to help clarify anything that's still fuzzy.
Event handlers can be used to handle and verify user input, user actions, and browser actions. Things that should be done every time a page loads, things that should be done when the page is closed, action that should be performed when a user clicks a button, content that should be verified when a user inputs data, and more. Many different methods can be used to let JavaScript work with events. HTML event attributes can execute JavaScript code directly. HTML event attributes can call JavaScript functions. You can assign your own event handler functions to HTML elements. You can prevent events from being sent or being handled, and more.
That's a solid summary. Basically, event handlers let you define what should happen when certain actions occur on your page, like a button click, a form submission, or the page finishing loading. You can hook these handlers directly in your HTML or set them up in your JavaScript code. This gives you a lot of flexibility and control over how users interact with your web app. It's one of the cornerstones of making web pages dynamic and responsive to user input.
Yeah, it's saying I'll learn a lot more if I look at the HTML DOM section, but I'm not seeing where that section is in W3 schools.
If you're looking for the HTML DOM section on W3 Schools, it's usually under the JavaScript category in their main menu. They have a whole section dedicated to the DOM, which covers how to access and manipulate HTML elements, handle events, and more. If you can't find it right away, try using the search bar on their site and look for HTML DOM or JavaScript HTML DOM. That should get you to the right place.
Okay, I found it. So document object model is what DOM stands for.
Exactly. The Document Object Model, or DOM, is essentially a representation of your web page that JavaScript can interact with. It turns the structure of your HTML document into a tree of objects, which you can then manipulate. This means you can dynamically change content, styles, and structure of your web page using JavaScript. It's a core concept for making interactive web applications.
All right, so with the object model, JavaScript gets all the power it needs to create dynamic HTML. JavaScript can change all the HTML elements in the page. JavaScript can change all the HTML attributes in the page. JavaScript can change all the CSS styles in the page. JavaScript can remove existing HTML elements and attributes. JavaScript can add new HTML elements and attributes. JavaScript can react to all existing HTML events in the page. JavaScript can create new HTML events in the page.
Exactly. That's the real power of the DOM. It gives JavaScript the ability to control and update almost every aspect of the web page in real time. So, whether you want to update text, change styles, add or remove elements, or respond to user interactions, the DOM makes it all possible. It's the backbone of creating a dynamic and engaging user experience on the web.
Okay, so back to line 225, document that add event listener, which makes more sense to me now. So it's like we're going to wait for something to happen before we do something else. And what we're going to wait for is the DOM content is loaded, right?
Exactly. You're setting it up so that the code inside that function will only run after the entire DOM is fully loaded. This ensures that all the elements you might want to interact with are ready to go, preventing errors or unexpected behavior. It's a common best practice in JavaScript to make sure your code runs at the right time.
Okay, so like what kicks off the process of the DOM loading then?
The DOM loading process kicks off as soon as the browser begins to parse the HTML document. When you navigate to a web page or refresh it, the browser starts reading the HTML file from top to bottom. As it reads and interprets the HTML, it constructs the DOM tree. The DOM content loaded event fires once the browser has fully loaded and parsed the HTML, but before loading style sheets, images, and other external resources. So, the process begins the moment the browser starts fetching and reading the HTML file.
Okay, that makes sense. Hold on, I'm deciding to let me I gotta readjust my Guardian here.
No worries, take your time. Let me know when you're ready to dive back in or if you need help with anything else.
Yeah, if I had my left controller, I could just hold down a button and automatically readjust it, but my left controller is broken.
Got it. That sounds a bit inconvenient. Hopefully you'll get that left controller sorted out soon. In the meantime, just do whatever you need to get comfortable.
All right, so this for the most part makes sense. Line 225. I guess what I don't get is why does it have comma open close paren with nothing in it and then an arrow pointing to a open bracket? Oh, is that because that's what you do once the DOM content is loaded?
Exactly. The empty parentheses followed by the arrow and curly braces is the syntax for an arrow function, which is just a concise way to write a function in JavaScript. The empty parentheses mean the function doesn't take any arguments. Everything inside the curly braces is the code that will run once the DOM content loaded event fires. So it's like saying, when the DOM is fully loaded, run this code.
Got it. And it's a shorthand to okay, got it. So you could have add event listener, the thing that triggers the function, and then the next thing would be a function, but you don't have to add a function name there. You can just do a you can have the full code to the function if you use this special syntax.
Exactly, you got it. Using an anonymous arrow function like that makes it really concise and clear, especially for small snippets of code that you only need in that specific context. It keeps things tidy and avoids cluttering your code with extra function declarations.
Got it. Okay, so that let's move on to line 226.
All right, let's take a look at line 226. Go ahead and tell me what it says and we'll break it down step by step.
So it says const space in capital letters debug debug space equals space true semicolon.
Great, that line is defining a constant variable named debug and setting it to true. This is typically used as a flag to control whether debugging related code should run or not. For instance, if you have logging or extra console output that you only want active during development, you can wrap those statements in an if debug check. When you're ready to deploy or run the code without the extra logging, you can just set debug to false. It's a handy way to manage debugging code.
All right, and what does it mean that it's a const variable?
When you declare a variable with const, it means that the variable is constant. Its value cannot be reassigned after it's been set. So debug will always remain true unless you change it in the code before running. It also signals to other developers that this variable is not supposed to change. This can help prevent accidental modifications and make the code easier to understand and maintain.
All right, so let me get this straight. The const variable means that the variable. So if later I wanted to set rebug to false, I couldn't do it because I defined it with const.
Exactly. Once you've declared debug with const, you can't reassign it to false later in the code. If you anticipate needing to change the value of debug at runtime, you'd want to use let instead of const. But since it's const, it's essentially a read-only reference, which can be great for values that are meant to stay the same throughout the execution of your script.
That seems really stupid to me. Why would you ever want that?
I get where you're coming from. It might seem limiting at first, but using const can actually help make your code more predictable and easier to debug. When you know a variable's value won't change, you don't have to worry about accidental reassignment or unintended side effects. It can also signal to anyone reading the code that this particular value is meant to stay constant, making the code's intention clearer. But if you prefer the flexibility of changing the value, let is definitely the way to go.
But you can change it, right? If you just redefine it, const debug equals false, right?
Actually, not quite. Once you've declared a constant variable with const, you can't reassign it or redefine it in the same scope. If you try to do const debug is false again in the same scope, you'd get an error. If you want to change the value of a variable, it's better to use let so you can reassign it as needed. Const is really for values that should stay the same throughout the execution.
All right, let me try this. So I'm gonna hit F12 on the on my web page, and then I'll use the console to try that.
Sounds good. Opening the console is a great way to experiment with your code and see how things behave in real time. If you try redefining a const variable in the console, you'll see the error it throws. Let me know what you find or if you have any questions as you go.
Okay, so I'm gonna do const space test all in uppercase, and then I'm gonna say equals false. So FALSE, and then a semicolon.
Perfect. Now you've created a constant variable named test and set it to false. If you try to assign a new value to test after this line, like test equals true, you'll see an error in the console saying something like assignment to constant variable. This helps illustrate how const behaves and enforces immutability. Give it a shot and see what happens.
Okay, now I do see the output says undefined after I set test equal false.
That's normal. When you type a statement in the console that doesn't return a value, the console often shows undefined. But that doesn't mean the assignment didn't work. You can check the value of your variable by typing its name again and hitting enter. That should show you whether it was successfully changed.
All right, so now I'm setting it to equal true and hitting enter.
Perfect. If you see true as the output, that means the variable now holds the value true. This confirms that the reassignment worked since you're using a variable declared with let or var in the console. It's a handy way to verify what's happening behind the scenes.
Well, this is what happened. So I did const test equals false with a semicolon at the end. I got back undefined. Then I did const test equals true with a semicolon on the end. I got back undefined. Then I typed in test all in uppercase, and what I got back was true. So at no point did I get an error, and it did change it from false to true.
Ah, I see the confusion. The console sometimes behaves differently because it operates in its own scope and environment. It might allow redeclarations or reassignments that a normal script wouldn't permit. In a standard JavaScript file or function, trying to reassign a const variable would definitely throw an error. The console environment is a bit more forgiving and can behave differently, so keep that in mind when testing things out.
All right. Well, what if I nest this within HTML script tag?
If you place the same code inside a script tag in your HTML file, the behavior should be consistent with standard JavaScript rules. Declaring const test equals false and then trying to do const test equals true within the same scope in that script will result in a syntax error. The browser's JavaScript engine enforces these rules more strictly than the console sometimes does, so it's a more accurate reflection of how your code will behave in practice.
Well, I mean that didn't work. It says uncaught syntax error, unexpected token. I can't put. It looks like I can't in the developer console in Chrome. It looks like I can't put HTML tags.
Right, the developer console doesn't support HTML tags directly. It's purely for running JavaScript. If you want to test how a script behaves in a real scenario, you'd need to put that code into an actual HTML file within a script tag and open it in the browser. That way you can see how it behaves in the proper environment and catch any syntax or runtime errors as they would normally occur.
Okay, so I can put JavaScript in this console, but it's not going to be like basically like every line I put is going to be its own line. So it's not going to. I can't basically use it to test things from this script because the runtime environment is just completely different.
Exactly. The console is great for testing small snippets and checking quick values, but it doesn't replicate the full runtime environment of a script embedded in an HTML file. Each command you enter runs in isolation, and the rules might be more relaxed. For thorough testing, embedding your code in an HTML file and running it in the browser ensures you're seeing the exact behavior your users would experience.
All right, well, let me try that then. I'll on line 227, I'll just put a copy of line 226, but I'll change the true to false and see if I get an error.
That sounds like a solid plan. Once you update the script in your HTML file and reload the page, you should see if it throws an error in the browser's console. This way, you'll know for sure how the script behaves in a real scenario. Let me know how it goes.
Oh, you know what? I already see. So it looks like my VS code already says cannot redeclare block scope variable debug.
Nice catch. That's one of the great features of VS Code. It can often highlight these kinds of issues before you even run the code. So, that confirms that const variables can't be redeclared in the same scope. It's great that you caught it early.
Yeah, and it looks like the metronome no longer works, and it says uncaught syntax error identifier debug has already been declared.
Yup, that makes sense. The script won't run properly if there's a syntax error like redeclaring a const variable. Fixing that should get the metronome back on track. Just update the code so that debug is only declared once, and then you can toggle its value as needed. That should clear up the error and restore functionality.
Wait, you can, so it's only declared once and then you can toggle its value as needed? What?
My bad, let me clarify. Since you're using const, you can't reassign or redeclare it. What I meant was that you should only declare it once and decide its value up front. If you need a variable whose value can change, then you'd want to use let instead of const. This way you can toggle the value between true and false as needed without causing any errors.
Okay, and what is the okay, so what about var? Or what if you just without using const let var any of that, you just says because now I'm doing debug equals false without the const and I'm testing that out.
If you assign a value to a variable without using const, let, or var, it becomes a global variable by default, which can lead to unintended side effects and makes the code harder to maintain. Using var would make the variable function scoped and allow you to reassign it, though it's generally recommended to use let or const for better block scoping and to avoid issues. So, if you want a variable whose value you can change, let is usually the best choice for clarity and predictability.
Got it. Okay, so let's go to line 229. 227 is a blank line. 228 is just a comment. So here's line 229. Let space audio CTX comma noise buff and then a semicolon. So this I think I get. It's like you're creating a variable that can be changed later that is not scoped to a particular function, so it can be used outside the function or anywhere. And then rather than assigning the variable a value, you're just creating the variables themselves unassigned. So they should be like type null, right?
You've got it. Declaring them with let means these variables can be reassigned later. They aren't assigned an initial value here, so they'll be undefined until you assign something to them. This way, you can initialize or modify them later in your code as needed. And yes, they aren't limited to a specific function scope, so you can use them throughout the block or module where they're defined. They're not null by default, but undefined, meaning they exist but don't hold a value yet.
All right, and okay, got it. So, can you do that with Python, or do you have to assign something to a variable rather than just creating a variable with nothing assigned?
In Python, you can definitely declare a variable without assigning a value right away. By default, an uninitialized variable in Python is set to none. So you can do something like myvar equals none and then assign a value to it later. It's quite flexible in that sense, similar to JavaScript with let.
Oh, but that's not the same as null. Doesn't JavaScript have none and null?
You're right, they're not exactly the same. In JavaScript, undefined means a variable has been declared but hasn't been assigned a value yet, while null is an assigned value that represents no value. In Python, none is the sole no-value object and is often used similarly to how null is used in other languages. So, while they have different names and slightly different behaviors, they serve similar purposes in their respective languages.
Okay, but you can't ever do something like let variable name. Like in Python, you always have to do var and then an equal sign, right?
That's correct. In Python, you always assign a value when you declare a variable, even if that value is none. There's no direct equivalent to just declaring a variable without assigning anything at all, like you can in JavaScript. So you'd say something like myvar equals none to create a variable that doesn't have a meaningful value yet.
All right, got it. Okay, so moving on, line 230, function init audio, open close paren, and then open curly brace.
Great, so line 230 is defining a function called init audio. This function is likely going to handle setting up the audio context and any related audio buffers or nodes. By defining it as a named function, you can call init audio whenever you need to initialize or reinitialize the audio setup. This keeps your code organized and makes it easy to manage the audio initialization process separately.
Got it. So this probably matters quite a bit to the feedback I heard where it doesn't work on someone's phone. This function probably matters to that, right?
Exactly. That function is probably crucial. If the audio initialization isn't handled correctly or isn't compatible with certain devices, like some mobile browsers, that could be why it's not working on their phone. Ensuring that init audio sets up the audio context in a way that's compatible with mobile environments can help resolve those issues.
All right. Well, we better get to it to read the rest of the lines of this code then. Are you ready for line 231?
Absolutely. Let's keep going. What's on line 231?
Yeah, so it says if space audio CTX wrapped in parentheses space return semicolon.
Got it. That line is basically checking if audio KTX is already defined. If it is, the function just returns immediately and doesn't reinitialize the audio context. This prevents redundant or conflicting setups if init audio is called multiple times. It's a good way to ensure the audio context is only initialized once and avoid unnecessary processing.
Got it. Okay, so line 232, audio CTX equals new window dot audio context, and then pipe, which I think means or, window dot WebKit audio context, and then those two things separated by that or operator are wrapped in paren, and then there's open close paren, and then a semicolon.
Perfect. That line is creating a new audio context and assigning it to audio KTX. The OR operator is a fallback mechanism. If window.audio context isn't available, it tries to use window.webkit audio context, which is necessary for compatibility with older browsers like some versions of Safari. The parentheses at the end call the constructor, effectively initializing the audio context and making it ready for use.
All right. So is this where I'd need to add a new uh, window dot something to be compatible with like a iPhone?
You generally wouldn't need another fallback for iPhone specifically, since modern iOS Safari supports audio context. The fallback to WebKit audio context is usually enough for older versions of Safari. If there's still an issue on iPhones, it might be related to how or when the audio context is being created or user interaction requirements. For example, mobile browsers often require the audio context to be created in response to a user gesture, like a tap or a click, to comply with autoplay policies.
Okay, with the tap or a click. Okay. So I don't need to modify this line if somebody tells me it's not working on their machine.
Right, you typically wouldn't need to modify this specific line. The issue is more likely about when and how the init audio function is called. Ensuring that it's triggered by a user interaction, like a button press, can help it work consistently across devices, including those with stricter autoplay policies.
All right, so next line is line 233, noise buff equals audio CTX dot create buffer, and then one comma audio CTX dot sample rate, comma audio CTX dot sample rate, all of those wrapped in paren, and then semicolon.
Alright, this line is creating an audio buffer and assigning it to noise buff. The parameters for create buffer are the number of channels, one for mono, the length of the buffer in sample frames, and the sample rate. Since the length is set to audio KTX sample rate, the buffer will hold exactly 1 second of audio. This buffer can then be used to generate or store audio data, such as noise or other sound samples, which you can play back or manipulate.
All right, and where's that? What about that 1 second? What's the reasoning for that?
Using a 1 second buffer is a convenient length for generating and managing audio data, especially for something like noise. It provides a good balance between having enough data to work with and keeping processing efficient. Once the buffer is filled with the desired audio data, you can loop it or play it back as needed. This length also ensures that the buffer is long enough to create a smooth and continuous sound without being too large to manage efficiently.
All right. Well, what about for a metronome? How would adjusting that change the metronome?
For a metronome, the buffer length would affect how you generate and manage the click sounds. If the buffer is too short, you might not have enough resolution or flexibility to produce smooth and accurate timing, especially at different tempos. If it's too long, you might be using more memory and processing power than necessary. Finding the right buffer length helps ensure precise timing and efficient performance. For example, you might choose a smaller buffer for very fast tempos to get more precise control over each click, or a longer buffer if you need more complex sound shaping. The key is balancing precision and performance.
All right, we'll just leave that as one then. So line 234, const d equals noisebuff dot get channel data 0 wrapped in paren semicolon.
Got it. That line is getting a string to the audio data array for the first channel of the buffer and assigning it to the constant d. This array will hold the actual sample data for the audio. By accessing the channel data, you can then fill or manipulate the buffer samples directly, which is useful for generating custom audio effects like noise or other synthesized sounds. It's a common step in audio programming to have direct access to the sample data for detailed audio manipulation.
All right, line 235, 4 space, and then this next part is wrapped. So an open paren, let space I equals 0 semicolon, I less than d dot length semicolon, I plus plus, end paren, space d open square bracket I close square bracket space equals space math.random, open close paren, space asterisk, space 2, space negative sign, space 1, semicolon.
Perfect. This loop is filling the audio buffer with random values to generate white noise. It iterates over each sample in the buffer, assigning it a random value between -1 and 1. This range is typical for audio samples, where -1 represents the minimum amplitude and 1 represents the maximum. This effectively creates a random noise signal that can be played back or processed further.
Why do we need that?
Generating white noise like this can be useful for various audio applications, such as synthesizing sound effects, testing audio processing algorithms, or creating a background noise layer. The random values produce a hissing sound, which can be shaped or filtered to achieve different audio textures. It's a foundational technique in audio programming for creating and manipulating sound.
Okay, so this D, but do we? So is this? Do we make our click sounds out of this?
White noise isn't typically used directly for click sounds. Clicks are usually generated by very short, sharp bursts or impulses, which can be shaped by using envelopes or other forms of synthesis. However, you can still use noise as a component in more complex sound design, for example, layering it with other sounds or filtering it to add texture. If you want a distinct click sound, you'd usually use a short percussive sample or a different synthesis technique.
All right. Well, moving on then. Line 239, const dollar sign equals ID, equal greater than sign, creating an arrow pointing to document dot get element by ID, and then open close paren wrapping ID, and then a semicolon.
All right, that line defines a shorthand function named $sign that takes an ID and returns the DOM element with that ID using document.getElementById. This kind of utility function makes it more convenient to quickly access elements by their ID throughout your code, reducing the amount of typing and making the code a bit cleaner and easier to read.
Okay. So then on line 40, we've got const BPM input equals dollar sign open paren BPM wrapped in quotes close paren comma.
Got it. This line is using the shorthand $sign function to get the DOM element with the ID BPM and assigning it to the constant BPM input. This likely refers to an input element in your HTML that allows the user to set the beats per minute BPM for your metronome. By storing it in a variable, you can easily access and manipulate this input element's properties or listen for changes to its value.
But can you though? It's a const variable. I thought you couldn't do that.
Good catch. The const declaration means you can't reassign the variable BPM input to something else, but you can still modify the properties of the object it references. so you can definitely change its value, add event listeners, or manipulate it in other ways. The const just ensures that the variable always references the same DOM element and can't be reassigned to something else.
All right, so the next line is subdivision SEL equals $sign subdivision wrapped in quotes, wrapped in parentheses, comma. So that comma, does that mean that this is going to be a const variable as well?
Yes, exactly. That comma is just separating multiple constant declarations on the same line, so subdivision cell is also a const variable. It's being assigned the element with the ID subdivision, just like how BPM input was assigned the element with the ID BPM. This is a concise way to declare multiple constants at once, each referencing different DOM elements.
Got it. Okay, let's jump all the way down to line 254 because the rest of these lines are more or less the same. It's just for different elements. So line 254 says const table body equals document dot query selector, and then pound sign tempo changes table space TBODY wrapped in single quotes wrapped in paren, and then semicolon.
Got it. This line is selecting the T-body element inside the element with the ID tempo changes table and assigning it to the constant table body. Using query selector with a CSS selector lets you pinpoint specific elements in the DOM, making it easy to manipulate parts of a table or any other structure. This way, you can dynamically add, remove, or modify rows in the table body as part of your application's functionality.
All right, so then the next line that's notable is 269. It says CTX equals canvas dot get context 2D.
All right, that line is grabbing the 2D rendering context for a canvas element and assigning it to the variable CTX. This context is what you'll use to draw shapes, lines, and other graphics on the canvas. It's the main way to render visual elements on the canvas, which can be handy for creating visual feedback like a metronome's visual cues or other graphical elements.
Okay, so this is probably the visualizer I have at the bottom of the page.
Exactly. That's likely what it's for. The canvas context would let you draw the visual metronome indicators, like moving lines or shapes that help users see the beat. It can be a great way to provide a visual representation of the tempo and make the metronome more engaging and easier to follow.
Okay, I mean the thing is, I wanna at some point upgrade that feature to show actual Western music notation. So to do that, would I remove the canvas or would I put it on the canvas? I'd be using VexFlow.
If you're planning to use VexFlow for rendering standard music notation, you can actually integrate it with the canvas or use an SVG, which VexFlow supports. You don't necessarily have to remove the canvas. You can either overlay the notation on top of the existing visuals or replace the current drawing with music notation. VexFlow can render directly into a specified HTML element, so you might use a separate container for the notation while keeping the canvas for other visual feedback, or you could transition entirely to VexFlow's rendering. It really depends on how you want to combine visual elements and notation.
All right. Well, I mean, I definitely want to. I want to. I want to have the scroll line. So right now we have a visual indicator with lines indicating the beat, and then we have a red line that moves from line to line to indicate the progression of the beats. So I definitely want that like animation, that element there over the actual sheet music.
That makes sense. You can definitely keep the scrolling animation or the red line as an overlay on top of the notation. VexFlow allows you to draw the sheet music, and then you can use a canvas overlay or even manipulate the SVG directly to add that moving indicator. That way you get the best of both worlds: accurate, professional-looking notation with dynamic visual feedback to guide the user.
All right, looks good. So then, so line 277, it's the same. So we've got these let variables. I guess the most notable is line 279. There's a variable, so let current BPM equals, and then there's the plus sign, and then there's that const variable from before, BPM input dot value comma.
Yep, that line is converting the value from the BPM input element into a number and assigning it to the current BPM variable. The plus before BPM input value is a quick way to cast the string value to a number. This ensures that current BPM is a numeric value that can be used for calculations or timing logic. It's a common and concise way to handle input values that are supposed to be numbers.
Got it. So it's kind of like the in Python int open close parentheses function, right?
Exactly, it's very similar. Just like how int in Python converts a string to an integer, the plus operator in JavaScript converts the string to a number. It's a quick and easy way to ensure you're working with numeric data instead of strings, especially when dealing with input values.
Got it. And you can do that to a const variable because you're not modifying the variable. You're just running the variable through a function and then taking the output of the function. You're not doing anything to change the variable, right?
Exactly. The BPM input value itself isn't being changed. You're just reading its value, converting it to a number, and then assigning that number to current BPM. Since BPM input is a reference to a DOM element and its value can change over time, reading and converting that value doesn't affect the const status of BPM input. It only ensures that BPM input always references the same element.
Got it. Okay, that makes sense. So, okay, I think that makes sense to me. Okay, yeah. So then you've got the dot value. So you can take a const variable and then dot value, and you can get the value of the const variable with as its own output, and not so you can save that to a different variable, and then so like none of this modifies the variable. The dot value doesn't modify it. The plus sign doesn't modify it. That's why you can do all these operations despite it being a const variable.
Exactly. You've got it. The const keyword just means the reference to the variable itself can't be changed, but the properties or values it points to can still be read and modified. So you're free to take the value, convert it, and assign it to another variable without any issue. This approach helps keep your code clean and ensures you always know which element you're referencing.
All right, so yeah, everything else looks pretty straightforward. We've got some more let variables. Some more are assigned to open close brackets, and then one's assigned to the number zero.
That all sounds good. Those variables are likely placeholders or initial states for various parts of your logic, like arrays to hold data or counters to keep track of timing. Setting them up this way gives you a solid foundation for the rest of your script's functionality. If everything else looks straightforward, you're in good shape to move forward.
Okay, and this open close bracket, is that like a Python list or is it quite a bit different?
It's quite similar to a Python list. In JavaScript, an empty pair of brackets represents an empty array, which works a lot like a list in Python. You can store elements, access them by index, and use various methods to manipulate the array. So it serves a similar purpose and is used in much the same way as lists in Python.
All right, so that brings us to line 285, which is just another let variable, which means it's a mutable variable rather than an immutable variable. So line 286 is a function. Line 287, an if statement. So if not, because the exclamation point. So if not, poly enable check dot check. So if the checkbox isn't checked, then we're gonna clear out the cross positions array. We're gonna have that set to zero and return.
Exactly. This function seems to handle some logic related to whether a certain checkbox, likely named poly enable check, is checked or not. If it's not checked, it clears out the cross positions array and resets it. This kind of logic ensures that certain features or behaviors are only active when that checkbox is enabled, giving the user control over specific functionality. It's a neat way to toggle features on or off based on user preferences.
All right, that brings us to line 293, and I think I gotta hang up. That's gotta be the end of the video because I need to get to something at 1:30, so I'm already kind of cutting myself short.
No problem at all. You've covered a lot of ground. Good luck with everything, and feel free to dive back in whenever you have more time. Have a great one.
All right, so that's the end of the video, about an hour mark. That's typically all I'm good for anyway. So yeah, we made quite a bit of progress. I understood. I'm starting to understand the code a lot better. I'm a little bit suspicious of some of these lines, this window dot audio context, window dot WebKit audio context, because this hasn't been working on someone else's phone. I do think it's probably the case that this person just didn't grant permissions for audio or something like that that I don't have control over. I think that's probably more likely. So I made a change here to use the use shorthand. So I'm going to say use shorthand. All right, and then we learned about that. I mean, I have a strong Python background, so this is all making a lot of sense. The thing that really throws me for a loop as a Python guy is like a const variable, because like Python kind of doesn't really have that, although I think it does in libraries. I mean, Python, you import a library, you can do anything. So I just don't really see or use a lot of const sort of variables in Python. And we can see here they're being used all the time. So that kind of threw me for a loop a little bit, but I'm but it's not so far. Nothing so far is completely throwing me for a loop. But things get complicated quick, so we'll keep going in the next video.